Need to track transaction details, but tired of digging through raw server logs? You'll see how FastMCP's structured logging sends rich transaction data, like IDs, amounts, and currency, directly to the client in real time, making debugging and auditing effortless. The pattern uses ctx.info with an extra dictionary to attach machine-readable metadata to log messages, so clients get both human-friendly updates and structured data for analysis.
At MCP, tool. Async def process transaction ID, SDR amount, float ctx, context. Await ctx.info. F processing transactionid. Extra equals. Transactionid. Amount. Currency, USD. Hash, processing logic.
This demonstrates the client-server logging pattern, where backend services emit structured messages directly to connected clients. Unlike traditional server-side logging that writes to files or consoles, this approach treats logs as first-class communication between server and client. The distinctive aspect is its dual purpose, providing real-time visibility to clients while maintaining server-side audit trails. The pattern works through a shared context object that abstracts the logging transport layer. Your tool logic remains focused on business operations, while the context handles message serialization, level filtering, and delivery to all connected clients. This separation enables consistent logging behavior across different client types, from development interfaces to production monitoring systems. This approach solves the observability gap in distributed systems by making server activity visible where it matters most, at the client level. It's particularly valuable for long-running operations, debugging complex workflows, or compliance scenarios requiring detailed audit trails. The trade-off is increased network traffic, but the benefit of real-time client awareness typically outweighs this cost in interactive systems. Let's break it down line by line.
At MCP, tool. Async def process transaction ID, SDR amount, float ctx, context.
This defines an AI callable tool using FastMCP's decorator pattern. The @MCP tool decorator exposes this async function to AI models, while the context parameter enables logging and progress reporting, standard for all FastMCP tools. Type hints automatically generate the tool's schema for AI interaction.
Await ctx.info.
This logs structured information to FastMCP's execution context. The await ctx.info pattern ensures progress tracking and observability, while the extra dictionary attaches machine-readable metadata to the log entry.
F processing transactionid.
This is an F string that dynamically inserts the transactionid into the log message. It creates human-readable context for debugging while maintaining the structured logging data in the extra parameter.
Extra equals.
The extra dictionary attaches structured metadata to the log entry. This enables log aggregation systems to parse and filter transaction details programmatically, rather than relying on unstructured log text.
Transactionid.
This attaches the transaction ID to the log entry's structured metadata. Critical for debugging, as it links logs to specific transactions across distributed systems.
Amount.
This adds the transaction amount to the structured log data. Critical for debugging and auditing, as it ties the numeric value to the transaction ID in logs.
Currency, USD.
Hardcodes the currency as USD in the logging context. Ensures all transaction logs include standardized currency metadata, preventing ambiguity in financial records. This follows the pattern of embedding critical business context directly in structured logs. This closing curly brace terminates the extra dictionary passed to ctx.info. It ensures all transaction metadata is properly structured for logging, including the transaction ID, amount, and currency. This closes the ctx.info call, finalizing the structured log entry with both the message and metadata. The trailing parenthesis ensures all arguments are properly passed before execution continues to the processing logic.
Hash processing logic.
This placeholder marks where the actual transaction processing logic would execute. In a real implementation, this would contain validation, database operations, and external API calls to complete the financial transaction. The ctx.info logging above provides observability, while this section handles the core business logic. Structured logging pattern. FastMCP's context logging with extra parameters bridges human-readable messages and machine-queryable data, creating logs that serve both developers and AI systems simultaneously. The extra dictionary must contain only JSON serializable values, or they'll be silently dropped from the logs. This pattern transforms debugging from reactive to proactive by making logs queryable before you even know what you'll need to search for.
The log message that speaks to humans hides structured data that speaks to machines. Yet both conversations happen in the same breath.